Good morning and welcome to this session of Business Breeders, a live webinar series hosted by Goodman Group at Brock University. My name is Abdul Rahimi and it's my pleasure to serve as the director of Goodman Group in the School of Business here at Brock University in the beautiful Niagara. Goodman Group is a community-focused learning and development services provider that works to support professionals, businesses, and entrepreneurs pursuing growth through accredited professional development certificate programs, executive education, consulting services, and startup support. It's my pleasure to welcome you all to this session as you take a break with us by taking part in this webinar. I'm making a note of the many individuals coming from not just around this beautiful region, but also around the country here in Canada, including those that are coming to us from the States and from other parts of the world as well. So good afternoon and evening for all of those that are joining us from other time zones. This webinar series aims to provide 45-minute breathers filled with insightful discussions on timely topics that are relevant to businesses as well as everyday lives. These sessions are led by our award-winning Brock University faculty and significant and leading industry experts in encouraging thoughtful debates and keeping us feeling connected as we get through this together. This webinar series is hosted on Wednesdays from 11 to 11:45. Momentarily, I'll be handing the screen over to today's webinar lead, and we are blessed with Dr. Ahmed being here that will be leading the discussion. Dr. Ahmed will speak for approximately 30 minutes. Then we will have some time answering your questions. You can pose your questions using any one of the following methods. You can pose them at the time of registration, and we have received a number of those. You can type them in the chat feature during the session, and that live session is live and open now, and you may type your questions right there. Also, you may tweet your questions, and they will come at BSB Goodman Group, all one word. That will be coming out. At the end of the webinar, I will provide some details on how you can access today's webinar recording. Now, it's my pleasure to introduce today's webinar lead, and that is Dr. Ejaz Ahmed, who is a professor and dean of the Faculty of Math and Science here at Brock University. He is an internationally known scholar and an established researcher. His research interests concentrate on big data, which is the topic of today. Predictive modeling, again, thing that we'll talk about. So data science and statistical machine learning with applications in many walks of life. Many of those items that will be touched on today, of course. His research has been supported by a variety of grants from the Natural Sciences and Engineering Research Council of Canada since 1987. The Institute of Health and Research in Ontario Centre of Excellence. His INSERT grant was renowned in 2017 for another 5 years. So another 5 years of INSERT and those individuals benefiting from Dr. Ahmed's outstanding work here. And it was giving an outstanding score in all 3 categories. Recently, he was also awarded the prestigious Bao Lang by the Asian Chair Professorship. Professor Ahmed has authored or co-edited several volumes and special issues of scientific journals. He is in the process of finalizing special issues of 2 different journals. And Dean Ahmed has been the Technometric Review editor for the past 10 years. He is a past member of Board of Directors of the Statistical Society of Canada, Chair of its Education Committee, and Vice President of Communications for the International Society for Business and Industrial Statistics, and a member of Discovery Grants Evaluation Group and the Grant Selection Committee for the Natural Sciences and Engineering Research Council of Canada. He is well published with approximately 200 research articles in scientific journals and reviewed more than 100 books and traveled the globe doing 200 scholarly presentations and parenting, of course. His achievements are many, his accolades are several, so little time. And the time here I'm going to dedicate to you hearing from Dr. Ejaz's expertise. Welcome, Ejaz, to today's session.
Thank you very much, Abdul, for your kind and generous introduction. Much appreciated. So here we go.
Thank you for sharing your screen, Ejaz, as that comes up.
Here you go.
Excellent.
All right. So once again, thank you to Abdul and his team and the Goodman School of Business for organizing this event. And it is my pleasure to spend some time with you, and thank you to all of you for spending time with me in this morning. So this is a joint work with Ejaz Ahmed from Western University, and she's here, happens to be my daughter. So I will be talking about the big data analytics. I mean, there are some pitfalls and there are some advantages. So I'm not sure if some of you are from outside the region or maybe outside the country. So this is I say pictures from my backyard, although it's a little bit exaggerated. It's a 10 minutes drive from my home to Niagara Falls. So let's start with this slide about which you can, if you Google it, hype circle, and you will find it. So the big data reached the peak of the hype cycle for emerging technology in 2013. So it's pretty much 7 years now, but still it's a very important area and continue to be very important. So since I'm making this talk for mostly for business community, so I will just talk about some things in business analytics. So you start with descriptive analytics by using historical data and simple descriptive statistics, and then you go into the predictive analytics. So that's one of the most important part is how we can predict and how we can use this prediction in our favor using some statistical model and nowadays machine learning techniques. And then it's come to prescriptive analytics, which is very important part of it after doing the prediction. So without prescriptive, for business point of view, you cannot use the information which you get from the data through prediction or anything else. So I will show you a slide from a business professor. So it's talk about the level of business impact and the skill levels required. Probably it will give an answer to one of the questions which have already been asked. So, you start with descriptive. It's a reports, dashboards, what happened. And then the next step is to go to diagnostic. Why did it happen? So it means you have to do the data discovery. And then it's come to the prediction part. What will happen? Forecasting and simulation. So these 3 steps for success have been done with many business companies. Even most business company actually only doing first 2 steps. They don't go even to the prediction part. And then the most important is the prescriptive one of planning and optimization. What should we do? So there was a survey some time ago of a US company. You will be surprised to know that only less than 10% of business are doing the step number 4, prescriptive. And no wonder we get into trouble if we don't use and analyze the data properly. So prediction part can be usually done in math and stats department to the statistician very well. They are well equipped with the predictive modeling. But even is coming from a statistics background, those students, they have not much idea about this step for the prescriptive. So which is very important. So, you know, they say the data scientist is the most sexiest job, or will be a most sexiest job in 21st century. And who will get this job is the most sexiest person. And how you become a sexiest person? By following all the 4 steps. So it is, so you can very easily, some of the students in this seminar, if they can do these 4 steps, they will easily make a 6-figure salary or more very easily. And if you are a business owner, I would highly recommend to do all these 4 steps in running your business. So with that, so this is nothing to do in a way from big data. This is even small data you are analyzing, or medium-sized data, you have to do all these things. So these things are pretty challenging. First 2 steps are not that challenging, but it's become very challenging after predictive modeling and prescriptive part. And then if you have a huge data, it's become huge challenging problem. So let's go to next slide. So you hear the word of data science, you hear the word of big data, and then you, in some arena, you hear the high dimensional data. So what are these 3 things? Are they different, or we are talking something differently? So I would generally, when I give a face-to-face seminar, I ask audience, so if you want to answer this thing through your chat, I would like to see how many of you have an idea about this thing. So in fact, data science is a discipline. And actually, in the beginning of the century, it was recognized as a field of science. So then the question is, what is big data? What is high dimensional data? So this studying the big data or high dimensional data it's the discipline of data science. And now we can, the data was there, large amount of the data, but now we can store this data. And so now if we can store, then we need to analyze it. So the issue is, you know, we think if we have more information, we can do a better decision, but it could be a big problem itself. The too much information may not be valuable. So it can be a paradox. 2 reverse conclusion may hold. So we need to extract the data to make it valuable for future study. That's the aim. So we need to, in this case, pre-processing the data, and then we have to, people are doing data messaging and variable reduction already in the case of a small data, but this become more important when we have a big data. So data reduction, in fact, extracting the valuable information from big data is called the discipline of data science. So you may see many other definitions, but to me, this is more important definition of the data science. So now look at where is the data? We used to deal with the structured data before, but now the data is not even structured. So look at this picture. The data is coming from the unstructuredness. So the job is not that easy. You know, we can make 7 or 6 figure salary, but it's very challenging. It's not a joke. Data science is not a joke. It's required lots of good skills, as you saw in the previous slides. So let's, to understand the idea of the big data and the number of variables, let's talk about the data matrix. So that's the way we collect the data. So we have a data matrix. So what is data matrix? For example, you want to predict the height of a child based on height of a father. So you have a outcome and you have a data matrix of only one column, the height of the father. So data, if you have if you collect the data from the world, then your number of the father's height is very large. So we use the term N, that N is very large, so large volume of the data. And the second part of the data matrix is that the predictors, features are also very large. So what happened, so instead of the father heights, you included the mother heights or weight or other variables to predict the child height more precisely. So that is P. So now say you have 3 columns. So N by P. So I said 20 observation you took, and you have 3 columns for the P: height of father, height of mother, weight of father. So like father, like son story, you know. So N can be very large and P can be very large. So how P can be very large nowadays for especially predicting the height of a child? The genes. If you include the genes to predict the height, there are 20,000 genes can be used to predict the child height. So now your data matrix P is very large now. So it's instead of 2 or 3, it is 20,000 plus 2 or 3. So this is the scenario number 3, that you have only 20 people, 20 father heights or the 20 child heights. So you have only 20 observation, but now you have a predictors more than 20,000. So this is called high dimensional data, when the number of observation you have at hand is much, much smaller than number of the features or predictors, as you see in this prediction of the child height. So N is only 20, you can go 100 or you can do 200, but still the P is over 20,000. So that's the third very challenging problem when you have a high dimensional data. But in business, mostly you have a scenario 1 where N is very large. The observation is very, very large, and maybe few predictors or features are there. So that's the distinction between 3 cases. So as you know, that the volume of the data, amount of the data, various types of data, and the speeds of data processing, that's becoming very challenging, the volume and the processing. And for a statistical point of view, veracity is the most important point for us, uncertainty, and then the imprecision in the data. So how to deal with that thing, especially when data is too huge, too big, too large. So give you a couple of more examples. In genetic microarray studies, N is measured in hundreds, and now we can do in thousands, and the number of features P or D per sample can exceed millions. So this is the case of high dimensional data. And in fact, I was just watching the news today, and there are 2 chemistry professors have won the Nobel laureate for doing the genome editing. So I'm pretty sure the statistician and data scientists are behind this work, but they don't get the data science people don't get the Nobel Prize. So that's the thing. So this is very important area. And so for example, 22,500 unique proteins has been counted for, implies that 253 million possible protein to protein interaction. So just imagine the model with 253 million features to predict something. So you like a predictive engine, you put all the predictor one side and get the model outside. So when I was giving this talk somewhere, this one person choked about it. So you can have a predictive engine, put the variables one side, get the model other sides. Can we put a model one side and get the predictors outside? So we are not that far in that technology. So that's a high dimensional case. And Facebook data, so this is 950 million, even more. So this is the case when the observation is more volume. So 2 different cases once again. And then there is another issue when people are combining the different data sets from different sources. So we used to deal with the homogeneous data. Now the data is very heterogeneous, and how to combine them. That's another big problem. And that's where the bias also come into the picture. And again, you can, in industrial application, massive data are collected for statistical process monitoring. So one of the challenges in the processing and volume in the financial analytics. So for example, credit card company. We analyze this data and we published this paper in an information science journal, Entropy, about financial credit card example. In this case, you can see the number of observation is 980,000 and the number of features was about 45. So it's not a high dimensional case, but it is a large data set, and how to deal with that and how to build the model. And so we build a model, we provide some answers, but answers rise to more questions. So you have to be careful in the when you are dealing with such a data because of the heterogeneity, outliers. One or two in a small data set, one or two outliers can throw the results out from the reality. But if you have a huge data set, how to deal with the outliers and how to identify the outliers, those are the very important questions. And then rounding off errors. So that has been neglected for some time. Now people are catching on this rounding off errors, because if you have a huge data, if you keep rounding it, you are making a big error itself. So we need to be careful with, and the techniques are available. We develop a new technique based on some sophisticated mathematical techniques. And then there is another issue of the bias comes in the imbalanced data. And the data is skewed to one side or other side. And mostly in terms of the credit card fraud detection or credit scoring, the issue is the data is just like I say, volume and processing, they're coming too fast. And then there are most of them, fortunately, they are not with the fraud kind of the data, they're only few. But they get combined with all the data points, and then we may not able to predict precisely. So you can see $27 billion we are paying it. So who is paying it? It's not the credit card company is paying it. We are paying it through our interest rate or whatever the credit card company charges us. So this kind of problem only can be solved through a more sophisticated statistical and machine learning techniques. So in imbalanced data set, we can mitigate the risk by undersampling the majority group and oversampling the minority groups. But the issue is in the big data, the processing speeds and the volume. So it's in small data set, we used to do it very effectively, but it's a challenging problem how to do that. So let's talk about some of the techniques which many data scientists or data analysts are using it, machine learning techniques. Basically, most of us people who are doing it, they are applied people. They just plug into the software or use the built-in algorithms to get an answer. So there is for example, support vector machine, neural networks, Mars, multivariate adaptive regression splines, random forest, k-nearest, and there are some other. So these are purely more coming from the computer science based on the algorithm. And they build appropriate predictive model. You can plug in. But the important part with this technique that it comes a cost of interpretability. We don't know how many features they are selecting and how to interpret it. And also the reliability of the results. And all machine learning techniques are subject to bias. So the bias is the biggest issue, and also computational power. So now I will talk about some statistical model or statistical technique combined with the machine learning. We call it supervised learning. If you have an outcome, we call it supervised learning, outcome data. If there is no outcome, we are not predicting, then it's unsupervised learning. That's the word computer science people use it more. We call it mostly regression model. And most of the time in medical study and sometime in business, your outcome is a success or failure, yes or no. So that's where the logistic model come into the picture. So what happens if the data is high dimensional? Even it's not high dimensional, but P is quite large. Even say in our example, we have 45. We want to select only 5 or 6 strong predictors to make precise prediction and reduce the prediction error. So how to do that? And it's become a very difficult case when the n is much, much, much smaller than p. For example, the genetic array example, we call that 153 million predictors, and n is maybe 100. So the usual statistical techniques, if we are aware of it, it doesn't work. And why it's not work? Because we solve a system of the equation mathematically speaking. So if you recall your high school or intermediate school class of math course, talking about number of the equations and number of unknowns. So our high school teacher told us that if number of unknowns are larger than number of equations, we cannot solve the problem. So same problem here. When P is much, much larger than N, we can do it. So the new techniques came around the beginning of the century. One is we use the penalized likelihood methods. So the objective function is penalized. We penalize the objective function for having larger number of the parameter. For some of you, it's known, it's called lasso, and there are many, many other of them. I'm not to be, in respect of the time, I will not go there. So the lasso is good one. It's what it does. It's only select few predictors. So you have a 1 million predictors. It might only select 5 predictors to do the prediction part, to build the predictive model. So the assumption is there that model is sparse. So what's sparse mean? There are many predictors, only few are significant, less, and the rest of them are not significant. So do not need it in the model. We can throw them off. So that is the reason for creating the bias. If you have thrown some important predictors out of the model, you got a submodel, a small model with only few predictors, you are creating a big bias. So that's the important message of this talk. We have to watch for the bias. So sparsity is the name of the game now. If the model is sparse, this technique will work very well. You can do a good prediction based on the selected features. And I call it, from a big model, you have a submodel now. So submodel are good in a way that we can interpret them and they are efficient. But what's the problem with the submodel? And we can say, so this is most of the people are stopped there. They use either machine learning techniques or statistical techniques coined with machine learning and select a submodel, and then they say this is it, do the prediction part. So is it end of the story? Really? No. Let's dig in deeper. So it is a good strategy if the model is truly sparse, that the predictors you selected the right one. So you are, instead of overfitting model, you have a underfitted model now. So underfitted model or submodel estimators are biased. I can show you mathematically. If you are interested, send me email. I will send you some of my papers, or I will just send you one slide. So they are biased, and bias is the big problem in the big data set. So we need to control the bias, because if throwing one features create little bias, but throwing 1 million features or predictor will create much bigger bias. So we need to control the bias. So bias will increase with the number of predictors thrown out without a bound. So even there is no bound, it's keep increasing mathematically, and consequentially MSC is a measure. Average squared error measure will explode. So you have a predictive model, and then you are giving a prediction error, but this prediction error has no bound. It may explode. So it is not a good trade-off between bias and controlling the variation. So I paraphrase that all submodels are biased, but some are useful. So that's what I said, that the naive data analyst, data scientist, or data miner, whatever we call them, may not comprehend that by dropping some variables from the model, the impact will be drastic on the prediction error. So we need to be careful. So data science job is not a joke. It's required lots of strong skills to be a data scientist. So we have to make sure, we used to say when we started using the software package 30 years ago, we say garbage in, garbage out, because we don't know how the algorithm is written, what's going on. So we need to be careful. We have to be biased. It's the biggest problem. I keep repeating myself. So just, got this predictive model, got this prediction error, and then close our eyes. You might, the challenge, it can be challenged even in the court. I have myself appeared in court as expert witness few times. I got to be careful what I'm doing. So the law of unconsciousness will not work. In many cases, it do work, but in this case, when you are dealing with data science, it will not work. So the world of data is growing exponentially. So it is going on, and it will continue to go on. So we have to be start learning the new techniques. And in fact, this is almost 20 years in this big data business now. So far, we are doing pattern recognition, correlation, and predictive model. So we have to go into the next level. So the next level is wide open. What will be next level? How to define the next level? So we need much more collaboration and between among different disciplines. And as I said, the data is never neutral and unbiased. We must pull expertise across the host of fields to combine the biases in the estimation. So we have to be careful with the algorithmic based prediction. Some techniques we use. And what Hamming, as a computer scientist, said in 1962, the purpose of computing is insight, not only numbers. So now you see there is a clash of cultures, people who are being trained more like in statistical science. We used to work with pre-processed and sample data, classical assumption, exact analytical solution, low dimension data analysis, SAS, SPSS, and other packages we use. And we are idealistic, that everything is good. And then we work alone in a smaller team and glory of the individual. But now we have a big data available from different sources. And then the concept of population data and sample data is lost now. We don't know, people don't know which kind of data they are dealing with. So we have to frame the problem ourselves, identify the data for analysis. Is it from population or it is from sample? We need new tools for new data. For example, we all know Python and R, open data sources, parallel and cloud computing. If you have many data sets, you can't just do one by one. So people are using Hadoop, Spark, and others, and many more are keep coming. And then, as I mentioned, the problem is the combining data. It's called data fusion, record linkage. So there is lots of bias there. If you are not combining properly, you are using different sources, for example, tax return, court records, and health agency, and so on. So as I said, this is time for next level for the data science. We need to develop high dimensional statistical inference. So whatever inference we have, it doesn't deal with the high dimensional cases. We need to be pragmatic, think tanks, and the glory of the research team. And here are some of the references. I have been working since 2008 in big data myself. As Abdul mentioned, I have edited many volumes, and the work is keep going. Work never stops. And then about the processing the data, this is the entropy journal I mentioned. If anyone needs a copy of the paper, they can send it to me, and some more references. And just thank you. to Abdul and his team, and thank you to all of you.
Thank you very much, Ejaz. That was very insightful. We've got a number of questions, both received at the time of registration, but also during the live session. So I'm going to put some of those questions to you in the time that we have remaining. Okay, starting off with one here. How do we ensure a good selection of predictors?
Yeah, that's a, you know, I don't like to say this is a good question. A question is a question. The question is never good and bad. So this is the question people are trying to answer from the day one. So the selection of predictors, as I mentioned, we statisticians do with the penalized likelihood. We have a likelihood function, and then we add the penalty function. So it's not 100% guarantee that the selected features are the really right one or not, but more importantly, they will reduce the prediction error, the one you selected it. So prediction error may not be impacted, but the bias might be created if we did not select the right one. So there are many techniques. I only mentioned about lasso. There is a SCAD, ENET, and there are other techniques. So I would suggest to use 4 or 5 different techniques and then look at it. And to basically, I can talk about my research. I didn't talk it. That's what I do. I say, okay, you select a sum model. You are not sure the predictors are right or wrong. So you go back to the full model, combine them together, and then you can reduce the bias. So there is techniques available to deal with that.
Right, excellent. Thank you for that. Here's the next one. Looking at your experience when conducting predictive modeling, might you share an experience when you came across an unexpected result? And then what would you have done about that? So
no, again, this is interesting question. So, you know, if I am working as a consultant, I used to work as a consultant. When I become dean, I don't do maybe conflict because of the conflict of interest, any consulting work. If I am doing for consultation, then I have to make sure I have to discuss with the people, my clients, about it, that, you know, you are looking for something, but model is not showing this thing, and it happens. But in terms of so there are many times it happened like that. In terms of the publication case, we don't report those ones. We report only the right one. But if you are doing a concerned real world works, then you have to discuss with your clients. And then there may be some issues with the data. There may be some additional data can help you. So yeah, there are situations like that. Always it will come.
Excellent. In regards to the sample size, what would be, and this question says, for something to be considered a very, very large data, what would be the end value, the specific end value?
You know, so during my this is question I used to face in my early stage of presentation around 2012. There were many questions like that. So my answer used to be depends on your computer. What is the capacity of your computer storage? So if it exceeds your storage, it's a big data. Then you take it to your company. That is so it's related to storage. But you know, in mathematically, n is infinity number. So is infinity is a theoretical number thing. So there is no hard and said that n is 100 is large or 1 million is large. So it depends on the problem and the data is collection. So sometimes if you cannot handle it, then you make a subgroup of your data. So especially, you know, sometimes we forget these things. If data is homogeneous, you don't have to deal with the whole big zillion of data numbers. You can take a subsample from there. But the problem if data is heterogeneous, which is what we are facing nowadays, then we have to be careful. So there is no, I mean, to give you a precise mathematical answer, there is no precise number for that. But the n is growing exponentially. We all know that. So,
so the n depends on the memory.
Exactly.
capacity of your machine and your circulation. All right, and of course the client. Fair enough. And then you've got some good solutions in there about taking a subset, maybe a stratified sample of type to make that happen. Excellent. Question here: how do you tell a good story when using data?
Oh yeah, the story, even nowadays publishing a paper is a storytelling. So you have to make sure there is if, for example, like when we were dealing with this credit card company data set, the story comes with the 3 points which I mentioned. Rounding off error. Most people didn't bother about this thing.
Right.
The rounding off error is there. So the good story is not the success story. It's a blend of success and the failure story. And the failure story is more important to me because it will lead to success, and it will lead you to find new methods and new ways to deal with the problem at the end. So don't be afraid of if you don't find a solution. That's fine. A good data story is not only about that, we solve the problem completely. No. So it has to be blend of it.
Here's a question that comes about application with a business setting in mind. So how do you achieve business goals by leveraging mathematical modeling?
Oh, mathematics is everywhere. And that's what happened, the business training, like MBA, there is not much time to do everything. They have to learn so many things. So now if you really want, if you have an MBA degree and you improve your mathematical skill, and when I say mathematical skills, it include statistical and computing skills, you will be selling yourself at very high price. So mathematical modeling is very important. But to convey the data story is not mathematical modeling. Mathematical modeling play at the background. But the story of data comes from the application and from your business perspective. So nowadays, the subject knowledge is one thing. We must be expert in our subject knowledge, but domain knowledge is also very important. So I may have lots of mathematical training and knowledge, but if I don't have a domain knowledge, it's a problem. So now it is expected more from us.
Right.
It is that we have to have a subject knowledge and we should have also domain knowledge. So this mathematical training questions come to subject knowledge. So it's very important that otherwise, if without the understanding of mathematical modeling, you are predicting something based on algorithm. If algorithm is biased, you don't know about it, so your results may not be precise. So once again, it is important, but how far? Like even a math student can continue learning math and it's never end. So at some point, you have got to end it somewhere.
Right. Good advice there. Here's another one. So in relation to big data, there's obviously opportunity for big data, and there's a push for big data to be collected and also to use for it to be analyzed. But of course, on the other side, we hear fairly commonly or consistently on news around data breach. The government of Canada, for example, has been affected by this, as well as local companies and organizations alike. So it's somewhat indiscriminate in that sense. What are your thoughts around that balancing of use of big data, but also ensuring safety and security of data?
I think that's the questions right away. This question arose when people are starting with big data. At that time, everybody was excited with big data. Nobody much talk about the security. So now the security is the biggest issue, and sometimes for the security issue, sometimes in some organization people cannot even use the big data. They will not allowed to use it. So that's the one drawback for not using big data, because you're not getting all the information. But on the other hand, the security is more important. It's the personal information, through the court records and everything else. Its personal information is going away, and somehow, if this linkage problem, and it could be a security issue for us at the airport, it happens sometime. Because they link, this is all classification over there. The guy asks you 10 questions, and out of 10 questions, then he classified you. Out of 10, 6 goes into one group. Okay, you stop here. We have to get you interrogation. So this kind of things. And then what happened? The data linkage was not done properly. With my last name, somebody else's last name connected, and something else come there, which is not part of me.
Yeah.
So the security is the biggest issue, but security is more like cost to from statistical perspective. It's cost to most for computer science people. So there is a lots of question on cyber security, and things are happening, and they have to, some more techniques has to come out and by computer science people. But not only, we have to be careful in data linkage when we are linking the individual person records, and that's the biggest bias can be created. So
right. Thank you very much for that. I know we have one more question here, so we'll try and, but we're also sort of time limited. What's your general procedure of dealing with big data and leading to insights?
Okay, so this is very near and dear to me. This is my part of my research, which I have been doing and preaching to other statisticians even. So to me, as I say, big data, we can do a predictive modeling. But the problem is in big data, if there are number of features or number of predictors are so many, so you can do it as select a sum model and do the prediction. I said, don't stop there. Go one step further. Try to bring a model with more features, combine them. And then, so I have a technique called shrinkage estimation. And then apply this technique, you will get much better results. Your bias would be controlled. So this is, to me, is the most important part. Don't stop after getting a sum model. Go one step further to reduce the bias.
Excellent. Thank you very much for that. Ejaz, I want to take this opportunity to thank you again for taking time out of your busy schedule to come here and be with us and share your thoughts and ideas and wisdom with our audience here who have joined us from literally around the world in today's session. Thank you very much, Ejaz.
Okay, thank you again. So I put this slide back, your last slides to show.
Yes, please. Thank you very much. And to all of our audience, to all of you joining in today, tuning in and taking your break and breathers with us, thank you very much for taking time out of your busy schedule and for being here and listening from our instructors and faculty and world-renowned individuals as we continue to bring such high-caliber individuals to this webinar series. A link to the recording of this webinar will be made available soon on our website, and you'll be getting those as part of our monthly newsletter as well. Next Wednesday at 11 to 11:45 again, I am joined by Stephanie Barnes from Berlin, Germany, who is the Chief Chaos Organizer at the company that she's working. So more to on that. That is Wednesday at 11 to 11:45. Details of this can be found on our website, and that's coming up as well. And also, for those of you that are here, wish you well, and hope many of you can join us next week. Until then, stay safe.